Figures A, B, and C are parallelograms. Figures D, E, and F are not parallelograms. Number one, the number of sides that a parallelogram has. Okay, so if we look at the parallelograms, the top three here, we count the number of sides. There's 1, 2, 3, 4. All of them have 4 sides, so we can write 4 sides. Number two, opposite sides of a parallelogram. So the opposite sides of a parallelogram, for example, this side and its opposite side, they are parallel. If these sides were to continue on in both directions, they would never meet, they would never touch. So they are parallel. The same is true with these two opposite sides. So the red sides are the opposite sides, the yellow sides are the opposite sides. They would be parallel, they would continue on forever, and they would never touch each other. So we would say, for number two, opposite sides of a parallelogram are parallel. So notice that the word parallelogram has parallel in it. So that's the reason for it. Okay, and number three, opposite angles of a parallelogram. So the opposite angles of a parallelogram would be, for example, this angle right here and this angle right here. They would have the same measurement. And then these two angles here are also opposite angles. They would have the same measurement. So we would say opposite angles of a parallelogram, they would be equal to each other. Here's an example in the summary that shows some number degrees for the angles, like 45 degrees, 45 degrees, 135 degrees, 135 degrees. So opposite angles are equal to each other. Okay, section 4.1 is done. We'll move on to the next section, section 4.2. Find the area of each parallelogram. Show your reasoning. Okay. I will take this parallelogram and decompose it from here, which is like a triangle, and then I can slide it over to the opening here, and it will fit perfectly right here. So now this part is gone, and I'm left with what looks like a rectangle. So I can just use length times width, or I can count all the squares and find the area. If I use length times width, I get 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is actually a square. So area would equal length times width, which is 6 times 6. So it would be 36 units squared. Units squared. I can do the same thing on this one. I can decompose it. And I can actually decompose it kind of anywhere in the middle here. So maybe I could decompose it from here and slide it over to the right. So it would look like this. So now what I have is this piece is gone and it's here instead. And this again looks like a rectangle. Rectangles are also parallelograms. And I can just use my length times width numbers, 1, 2, 3, 4, 5, 6. And the width is 1, 2, 3. So I can say area is equal to 6 times 3, which is 18 units squared. Okay, next section is 4.3. It says find the area of each parallelogram, show your reasoning. Okay, I can do the same thing on this one for part A. Maybe I can decompose a triangle from here, slide it down, let it fit in the gap right there. So now what I have is a rectangle. I'll highlight it here. So it looks like a rectangle, and I can easily find this area. 1, 2, 3 is the width. 1, 2, 3, 4, 5. That is the length. So I can just multiply 3 times 5 and get 15 units squared. Example B is a little bit more challenging. for this one, it's hard to decompose a nice section of it and slide it over. What you can do instead is create a rectangle around the parallelogram. So you can create a rectangle. So we can find the area of this entire rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9 is the length. 1, 2, 3, 4, 5, 6 is the width. So we can say 9 times 6 is 54. And then what we can do is subtract the area of the two triangles away from the big rectangle, and we'll be left with just the blue shaded region. Now, the two triangles, if you put them together, the two triangles together will form a rectangle. So if you slide this one over here and you slide this one over here, you get a rectangle. Let's see the length and the width of it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So I can say this rectangle would be 7 times 6, which is 42 units squared. And then what I would do is I would subtract it from the area of the big rectangle. I can say 54 minus 42, and I would get 12. So final answer for this one, 12 units squared. Okay, and then example C, I can just slide the triangle over. So I can slide it over to the right. I could fit it right there. And now this triangle is gone. I can just use the actual length. Even though I moved this triangle over here, the length is still the same. It's still 6 units. And the width is 4 units. The 4.5 I don't need. That's a slanted height. It's not the actual width. So I would just use the 6 and the 4. I would say 6 times 4, which is 24 units squared. Final answer. You guys can also look at the lesson summary, which kind of explains everything and shows you different ways you can decompose the parallelograms and then recompose it into a rectangle, which would make it easier to find the area.